Here we have the balanced equation. I've annotated it with the given mass of calcium carbonate, the given mass of hydrochloric acid. Those were given in the problem. I've also annotated it with the thing that we're trying to find primarily, which is how many grams of water are produced. In the process of doing that, we will answer the first two questions. So let's talk about our strategy. We were given grams of reactants. We must change them to moles. Then we will change those to moles of product using the ratio from the balanced equation, and then grams of product using the molar mass for the product. One thing to keep in mind, we can only use the limiting reagent to find moles of product. The first thing I've done is set up two railroad tracks. One so that I can convert the mass of calcium carbonate into moles of calcium carbonate, and the second is so that I can convert the mass of hydrochloric acid to moles of hydrochloric acid. Here you can see I've written down two numbers that are just a representation. They're not the entire number in my calculator. I'll continue to calculate using all of the digits in my calculator until I arrive at a mathematical answer. This is a good step that'll help me find the limiting reagent. I can find it if I divide each mole value by its coefficient. The coefficient here is an imaginary 1. The coefficient here is a 2. So I will divide this by 1 and this by 2. And then the smallest value is the limiting reagent. So this number divided by 1 is still 0.06. This number divided by 2 would be approximately 0.04, right? Because this is 0.08 if I round in my head, and half of that would be 0.04. So hopefully you can see that the second number will be smaller if I divide it by 2. So I'm just going to label this as the reagent, which means this is an excess. Therefore, the rest of the math that I do will start with the limiting reagent. I'll take this and just move it out of my way. I may need it later, but the limiting reagent dictates how much product will be formed, so I will use this railroad track to continue my work. Now I need to change moles of hydrochloric acid into moles of product. Finally, my last step is to change moles of water into grams of water. Now we can go back and fill in the numerical values. So what is the mole to mole ratio for water and hydrochloric acid? The coefficient in front of the water is an imaginary 1, so that is 1. And here we have a 2. 1 mole of any substance is equal to its molar mass. Now I'll go back and make sure that all my units have canceled properly. Moles of hydrochloric acid, that is set up properly. Moles of water. I do not round in the middle of my calculations. I keep all the numbers in my calculator until I get to the end and round. So I started with this value that has 4 significant figures. And I keep all the digits in my calculator that I get from the periodic chart because I do not want molar masses to limit my calculations. This is a count, so it's an exact number, so it does not limit my calculations. And the 1 mole here, that is a exact count as well. This is the answer to part C. the limiting reagent, excess. So to determine how much excess is left over, I'm setting up a small BCA table so that I can dim out all of the limiting reagent is used by definition, so none will be left over. To find how much calcium carbonate is used in this reaction, I must rely on my balanced equation. The balanced equation has a ratio of 1 to 2. That means every time 1 calcium carbonate is used, 2 hydrochloric acid are used. Or every time 2 hydrochloric acid are used, 1 calcium carbonate is used. So if this number is 2, then this number is 1, approximately half right here. But to actually find that number, I will take the 0.07 number and divide by 2, multiply by 1, and fill it in. Later, and I find the actual value that's represented with a 0.0782 number. Divide by 2, multiply by 1, and so the amount in excess is the difference between these two numbers. I'm subtracting these two numbers and write a representation. I take this number and multiply it by the molar mass to find grams. Percent yield is actual over theoretical times 100. So I'll simply plug in the actual value given in the problem, the theoretical value for the mass of water that was formed, and then multiply those by 100.